All right, continuing on with chapter 6, we're working through 6.1. It was kind of a long section. We had some building blocks of learning the distributive property, working about combining our like terms, and then order of operations. So we were building up to ultimately the goal of section 6.1 is to work on solving equations. Trying to find out what your variable equals. So I'm on the last page of this note packet in 6.1, and we're working through the equations there. I'm on number 27. Again, always feel free to pause the video, work these ahead. So we're using the steps above, which we talked about in the last video, how we clean up each side. So if this side, there's two sides, the equal sign divides it into a left and a right side. You want to clean up the left, clean up the right before you start moving any terms around. So then, once it's as clean as it can be, these do not combine, then I move my terms back and forth. The shortcut is to just say if a positive 2 is on the left, when you move it over, it becomes a minus 2. So then that moves it off of the left side, just leaving the 3x. The 17 and minus 2 is 15. And then we divide what's in front of the variable. You always want to divide by that because we want the x to stay. We don't want to move the 3x. We just want to get rid of the 3, and that's multiplied. So the opposite would be to divide. 3 divided by 3 makes a 1x or just x. Then do the same thing to this side. 15 divided by 3 is 5. Always check your answer is 3 times 5 plus 2 equal to 17. And so that would check out. All right, 28. So in 28, we see our first example where we need to use that distributive property we learned. So we would start on this left side, nothing can be done. That's simplified as it gets. On the right side, I can distribute this 2. 2 times t is 2t. 2 times 6 is 12. And then we have a minus 5. Then I can further simplify that. You know, the left side's not cleaning up. It's already simplified as it gets. But the right side had some work. Positive 12 and minus 5 is positive 7. So once you clean up each side as much as you can, then you move your terms back and forth. However, you need to move to get your variables to one side and your numbers to the other. So these t's on both sides, I need to move this over. I need to move the other way. It's okay either way, but the 2t, when it crosses over the equal sign, becomes minus 2t. And then I'll move the 11 to the right side. A positive 11 will be a minus 11. And then we can simplify 6t and minus 2t is 4t on the left. And then on the right, 7 minus 11, negative 4. And then the last step we always do is divide by what's in front of the variable. I guess the last step is checking, but the last to solve, divide by the 4. Divide by 4, that makes t positive t, and a negative divided by a positive is negative. Should be negative 1, and then check it. 6 times negative 1 plus 11, plug it back in, make sure it works. All right, number 29, we see a fraction up here, first fraction. Now, if it only has one fraction in it, we might not do a full-blown clearing of the fractions that we're going to see in a later example. So one fraction won't hurt us too much. We can just say if there's just one fraction in it, this is considered a divide, a variable divided by 4. The opposite of divide will be to multiply. So if you're dividing by 4 and you multiply by 4, which would be 4 over 1, that makes those diagonal 4s cancel or undoes the division. You know, always using the opposite operation. Well, what you do to one side, you have to do to the other. So also times it by 4, 4 over 1, and then a equals 12. Also, you might just notice that the answer would be 12, and you would know that just by thinking about it. What divided by 4 is 3 is really what it's saying. But that's the procedure to think it through. Sometimes we really don't need the procedure. I realize that, but it's good to understand the procedure when the problems get real convoluted, and you'll have a process you can always know works to get to the answer. All right, we did 30 on the last video, so I'm going to jump to 31. Another fraction example. Now this is a fraction example where I would recommend this process of getting rid of the fractions. This doesn't come up a whole lot, but when it does, this is a real handy procedure to help you get rid of the fractions. You look at all of your fractions and you say what's the least thing that every denominator will fit into evenly, which in this case would be 6. Then I times the left side by 6 or 6 over 1. Anytime I say times a whole number, you can put it over 1. Then times the right side. Keeping the balance there, we're allowed to do whatever we want to in an equation as long as we do it to left and right. Well, the thing is, multiplication distributes. So it takes the 6 times a half, and you can check 6 times a half, that would make just a 3x. And it's got an x still on it, you know. And then 6 times a third. 6 times a third, we can multiply that, and it would be 2x. And then lastly here, distribute the 6 times 2/3 is 4. By hand, the way I do that is you can cancel diagonally when you multiply, and then multiply what's left. 2 times 2 is 4. But anyway, that's a neat trick to get rid of your fractions, because fractions are a pain sometimes to work through. We would have had to got like denominators. It would have been a lot of work to do it without that trick. So then you proceed. That's 5 x's on the left. Then you divide by what's with your variable, and then you solve for x. X is 4/5. And again, that's a harder one to check, but use your calculator skills. Put the 4/5 in for the x and check it. All right, the next one, number 32. Has decimals in it. Now, usually students don't mind decimals as much as fractions, so you could work it with the decimals, and it's not as big of a deal. The fractions really can slow us down, but the decimals, you know, they're not so bad. But we do have a trick for getting rid of the decimals if you should want to do that. And you look at all your decimals and say there's just one place to move there, one there, one there. So if there would be, one term that had 2 places that you needed to move to get to the end of it, you go with the biggest amount of moves. So if I times this by 10, the decimal moves 1 place. So if I times the whole thing through by 10, you know, multiplication distributes, so it winds up applying to every term. It's just going to get rid of the decimals. Now, if I had one of these, like if that was 2.35, I needed to get 2 decimal points out of the way, then I have to times by 100. So by the biggest amount of moves you need to make. Anyway, 10 will do it on this. So multiplying by 10 on each side, again, that's that multiplication distributes. Timesing by 10 moves the decimal point 1 place and makes that a regular 5x. Then distributing moves that 1 place, making it a 23. And then again, 1 place. So it's just a nice, happy thing to do there. You know, you get rid of the decimals. The decimals and the fractions can be distracting. Then I throw the 23 across the line. And I have a 5x equals 26, right? Then I divide by 5, 26/5, and we can leave it like that, or, and usually we do, that's the best way to leave it, or we can make it mixed, but usually that's good. Always reduce though if there's a common factor, you know, you need, if they're both divisible by 2 or something, always reduce it that way. But improper is fine for what we're doing. All right, then last, number 33. I'm going to use the distributive property on this one. So clean each side up first so we can use our distributive property and make that 4t minus 12, bring down our 8. On the right side, distribute this 4, makes that 8t and minus 24. And again, you clean each side up as much as possible before you move your terms around. So on the left side, I've got a minus 12 and an 8, right? So that needs to be consolidated. Bring down your 4t, minus 12 and 8 is minus 4. The right side, just 2 terms, and they're not like terms. So that's as good as I can get it. So the best you can get, you should be able to get it down to at most 4 terms. 2 and 2 there, if you've consolidated. Then you move things across the line. Now I could go left or right. I'm going to take my variable though to the left side. You could go the right side though, but when I move it across the line, it becomes a minus 8t. That means I'm going to take my minus 4 to the right side, make it a plus 4. So 4t minus 8t, and you can draw a line here if you want, that's kind of optional, but you're simplifying, equal sign. Negative 24 and 4 is negative 20. So a lot of negatives going on there. This is the first one we've seen this happen. If the variable, if the coefficient in front of your variable is negative, you need to divide by this exact same sign because you need it to be a positive 1. you need -4 over -4 to cancel out and make positive 1t or regular t. That's what we're always trying to do, is solve for 1t or 1x. So you do need to divide by the same sign there for that to happen. Then whatever you do here, you've got to do here. So -20 divided by -4, final answer +5. And the way we know it's right, we check it. We plug it back in for these t's. And then say, let's see, order of operation, that'd be 2 times 4 is 8, 8 plus 8, that side would be 16. Here we get 5 times 2 is 10, 10 minus 6 is 4, 4 times 4, that side's 16. That's how we know we have the right answer. It checks back in when we plug it in, use the order of operation. All right, if you need more examples ever when you're watching these videos, always feel free to reach out to me and say, I need to see like number 1 or 2 or whatever on your homework set. Let me know there's one that you didn't get enough information from the examples I did. I'll be glad to make some more videos or personally just send you a note. So always reach out. Let me know if you need further examples.